All right, section 2 in chapter 13 is all about igneous rocks. So 13.2, just going to be talking about igneous rocks. So when you guys look at even the name of it, are there any other words that sound familiar to you that are part of that? Ignite. And what does that mean to you? If something ignites, we know it's going to start on fire, right? And igneous rocks get that name because the root word comes from that meaning. So forming igneous rocks, we're going to get them two different ways essentially. You're going to either have rock that's getting melted in the lithosphere, as you can see in the picture on the left-hand side, or we've been talking a lot about subduction. So when one tectonic plate is subducted underneath another plate, like you see in the picture on the right, it's going to melt. And when it melts, it's going to have that magma, which is less dense, rise up in the crust and then create igneous rocks. So igneous rocks form when magma or lava cools and hardens. And like I just said earlier, the whole reason why the magma rises is because it is less dense than the surrounding rock. So igneous rocks form when magma or lava cools and hardens. This can happen up on Earth's surface, so like you see in the picture on the left-hand side, or this can happen deep within Earth's surface. So it can be happening underground, as we speak, in most locations, just from magma cooling and hardening. Now, one of the things we talk about when we talk about igneous rocks is crystal size. Crystal size is really important when it comes to igneous rocks. Crystallization is the process by which crystals form and grow in size. So just like if you've ever made rock candy before and you get sugar crystals to grow, the same sort of scientific principle will actually form igneous rocks. Now, depending upon where those pockets of magma or lava cool and harden will give us igneous rocks that look different. So here's our two categories. You see them on the slide here. We see the words extrusive and intrusive. Going back to their prefixes again, look at their prefixes: extrusive, intrusive, X. If you're going to take an exit, you're going outside, right? Extrusive igneous rocks are igneous rocks that cool quickly, and because of that, they have what we call a fine-grained texture, or we don't really see crystals in them. Think of it this way: they're cooling off so fast, crystals don't have time to form. On the other hand, intrusive igneous rocks, so those are our rocks that you see in this picture towards the bottom, intrusive, inside the earth, those rocks are going to take much longer to cool off. It's imagine kind of like being in a cooler. Like let's say you take and you cook a whole bunch of chicken on the grill, you put it in the cooler, some sort of a cooler, obviously without ice, but you put this in a cooler, which a lot of people do this, by the way, pro grilling tip. It's going to take that meat a really long time to cool off. If you just took that same meat and you set it out on the picnic table, it's going to cool off much more quickly. So extrusive, outside rocks cool much more quickly, intrusive, inside Earth's surface. So what you will see in igneous rocks is if they cool off inside the Earth, as you can see in this picture here, left-hand side, that's what you're going to see. You're going to see crystal growth. So we can have really big crystals, we can have medium-sized crystals, but you see crystals. They took a long time to cool off. The picture on the right-hand side would be extrusive. You don't see large crystal size. It kind of looks boring. There isn't crystalline structure inside of there. So intrusive, inside the earth, extrusive, outside the earth. And here's just some other rocks showing you. So all of these are extrusive igneous rocks. So every one of them are formed from magma or lava that is cooled and hardened, and it has done so on Earth's surface. There is no large crystalline size here, and a couple of them in particular, for example, if you look at pumice and you look at scoria on the slide here, these are pyroclastic material. So these are what form when volcano explodes violently and it shoots all of this magma into the air, and it cools so quickly that there isn't even time for the air bubbles to escape. Pumice is really lightweight. If you've ever touched it before, they use it a lot like in bath scrubs, like, you know, it's really rough, so people use it to scrub dry skin and stuff. But that's what pumice is. It's completely full of air. You can actually get it to float in water, which is weird to think that there's actually rocks that float in water. Scoria is similar to pumice. You'll notice it's red in color, and it's red in color because it contains iron. Anytime we see in nature that red color like that, it usually is indicating to us that it was iron. Basalt, the one on the bottom there, the flat black kind of boring looking one, that's an important rock. It's what's found on a good portion of the ocean floor. So on those mid-ocean ridges where you have that magma coming up, cooling and hardening, that is basalt. It's also, when we look at the moon, the dark areas on the surface of the moon are basalt. Obsidian in the upper left-hand corner. Obsidian is also known as volcanic glass. It cools off extremely quickly. It is also, you can get it to be really, really sharp. And some applications it might even be used in surgical tools because it can actually be sharpened to a finer point than our metal tools are. So all of these are extrusive igneous, formed from magma or lava, cooling and hardening outside the earth. Didn't have time for crystals to form. Now these ones are intrusive igneous rocks. So these all also formed from magma or lava, cooling and hardening. I should be more specific and say magma cooling because we're talking about inside the earth. Remember, when it's inside, we call it magma. But it's inside the earth. So all of this magma had the ability for crystals to set up and form. These ones are what we call a coarse grain texture. That's how we would describe it in geology. So you can actually see the crystalline structure. And I'm sure one of these on here looks very familiar to you, granite. If you've ever looked at countertops before, there's a lot of countertops that are made of granite. So intrusive igneous rocks inside the earth, long time to cool off. So just to kind of reiterate these, because these are really important facts to know. So if there's no crystals or they're small in shape, they are extrusive igneous rocks. So they had a quick cooling time. It's what we call, I've said, fine grain texture. They cool off near Earth's surface. And then I gave you a few more examples, but we're going to list just two on here. So basalt and obsidian. Remember, basalt is that sort of flat black one, the one that's found on the bottom of the ocean floor. And obsidian is that volcanic glass one, the one that looks like black glass. So no crystals, extrusive igneous rock, cooled off quickly. Large crystals, intrusive igneous rock, slow cooling time. It's what we call a coarse grain texture. I can actually see the crystals there because they had the ability to take a long time to cool off and form crystals. Granite on the slide here is an example. Gabbro is another one. Gabbro, it looks similar to basalt, but you'll actually see crystalline structure inside there. We actually have a decent amount of gabbro up here in northern Minnesota. So it's so important for you just to kind of remember that whole extrusive, intrusive, and what does that mean? If it cools off really fast, you're not going to get crystals. If it cools off really slowly, you're going to get crystals. All right, so hopefully that all makes sense to you guys and you really are understanding the difference between intrusive and extrusive igneous rock.